All right, well, let's go ahead and get started. Is it Noor? Is that how you would pronounce your name, Noor?
Yeah.
Okay, awesome. All right. And Stephen, can you hear us yet?
You're on mute.
Yes, but I'm wondering if he can, let's see, unmute. Can you hear us okay? Nope. Hi, Sarah. Thanks for joining us. All right, so we'll just go ahead and get started. For tonight's live session, we're going to talk about scientific investigation, kind of going through the scientific method and what all it entails. So kind of a breakdown of how we're going to spend the next hour. We're going to take a look at scientific investigation for about 15 minutes. Questions and answers for about 15 minutes, and then we're going to kind of go over some pointers to keep time management the best we can. And then again, any questions or answers, or questions and answers at the end. Feel free to ask questions about any assignments. If you have any questions that pertain to a different assignment other than scientific investigations, you can go ahead and ask them throughout this hour as well. All right, so just kind of some housekeeping rules. So please go ahead and participate. Again, I was saying that it's always nice to have some participation so I don't feel like I'm talking to myself. There is a microphone that you can use. You can either mute yourself and then you can type in a response, or you can unmute yourself using that microphone. If you're in a loud place, noisy, maybe some kids running around, go ahead and mute your microphone so it cuts down on distractions for those that are joining us. Please use kind words when discussing different topics. I don't think this one's too controversial, so we shouldn't get into too much drama. And if you do need to duck out early, remember that these live sessions are recorded and then posted on your dashboard if you need to review the information. All right, so in order to fully understand the scientific method, we need to know what certain words mean. So we need to figure out what investigation means, and method, and experiment in order to fully understand. So we'll start with some definitions. What do you think it means to investigate?
To look into like deep or
Okay, to look at something a little bit deeper, a little bit more in detail. That's great. Exactly. Let's see. What we got up here. Where's it from? Sorry, just a minute. Okay.
Can you guys hear me?
Okay, so we're still having problems with audio? Okay.
I could hear you, Steve.
Okay.
I'm going to mute it because I'm in a library.
Audio sounds fine.
Yeah, okay, now I hear you, Stephen.
Okay, but I'm going to mute it because I am in the library. So.
Okay. All right, awesome. Excellent. Okay, so Stephen, what do you think investigate means? To experiment. Okay, good. Good. So if we look at the, okay, so if I got on to the dictionary.com website, that gives me a couple different information. So it means to examine, study, or inquire into systematically, search or examine into the particulars of, or examine in detail, to search out and examine the particulars of in an attempt to learn the facts about something hidden, unique, or complex, especially in an attempt to find a motive, cause, or culprit. So to experiment, to look into something a little bit deeper with more detail, all seems to fit. So looking at a different term, what do you think method means? How would we explain that term?
Like a solution that you could try to
A
get
solution
a
that we could
result.
try? Okay, awesome. Okay, so it would be maybe the way that we do something. Exactly, I like that. A method, again, looking at the dictionary.com, it's a procedure, technique, or a way of doing something, especially in accordance with a definite plan. A manner or mode of procedure, especially in orderly, logical, or systematic way of instruction, inquiry, investigation, experiment, and presentation, or an order or system in doing anything. So pretty much what we just talked about. So if I am thinking of making a phone call, how can I use this as an example of a method?
Can you say it again, please?
So
Like-
so we're looking and kind of trying to learn a little bit more about the definition method. How can I use making a phone call as an example of a method?
Figuring out who you're gonna call, maybe.
Okay, I think that would be the first portion of it.
Or I can't really think of it.
Okay, all right. Well, if we look at a phone, yeah, so you have to methodically dial the correct number to reach the right person. If so the area code in which I live is 419. If I were to dial that incorrectly, I'm not going to get the person that I wanted to talk to. So I have to make sure that the numbers are in order. And so, in other words, if you don't use the right order, I'm not going to get the person that I want to. So that is a method or an order in which something needs to be done. Okay, one more term. How would you explain experiment?
To try until you get the expected result.
Ooh, I like that. To try until you get the expected results. Very nice. To try again. I have a 5-year-old and his favorite thing right now is, I can't do that. Well, I'm sorry, you need to keep trying. To try something and to see what happens. Exactly. Good, guys. Thank you for your participation. So, it's going to be a test, a trial, or a tentative procedure, an act of operation, or an act or operation for the purpose of discovering something unknown or of testing a principle, and the conducting of such operations. Awesome. Okay, so why are these things important? Well, in order to scientifically experiment, we need to investigate using a certain method called the scientific method. Yay! Should have had some sound effects there. Okay, so the thing that I have to disclaim first is different scientists will portray the scientific method differently. Some will use different wording or even different steps. There can be as few as 5 different steps or as many as 11 different steps. So let's go to some examples right now. So this right here is a pretty basic example of the scientific method. Okay, we've got purpose, research, hypothesis, experiment, analysis, and conclusion. So a scientific method conducted of 6 steps. Okay, pretty simple. However, we could get much more involved. Okay, we could do lots more steps using different words, but they're basically the same method. Okay, so just know that there are different ways to write it along with different steps that can be added. If you research or Google scientific method, you're going to come up with a lot of different information. So I just wanted you guys to know that it's all the same, but just different wording. Okay, so step 1 is to ask a question. So this step begins with something that you have observed. So it's something that you're trying to answer or solve. So for example, why is the sky blue? You know, that's a common question among little kids. You're going to try and solve the who, what, where, when, why, which, or how. Which tree grows faster in Ohio? Why does it snow so much in November? You know, different things like that. Where in Ohio is the least amount of snow? Maybe.
Are you from Ohio?
I'm sorry?
Are you from Ohio?
I am, yes.
Me too.
Okay, so the question should show the relationship between the two variables. So it could be, how does one variable affect a different variable? Okay, so these would be some examples of our first step, or the question that we could investigate. So where do ocean currents come from? That would be a simple question based on my observations of the ocean. How do you keep an egg from breaking? Why does ivory soap float? Okay, that's a good one. The list can go on and on and on. What kind of examples of questions do you guys have that we could potentially write a scientific method for?
Why do certain fish live in certain parts of the ocean?
That is wonderful, exactly. We could even say, why do fish live in freshwater versus saltwater? Yeah, that would be another excellent question. Perfect.
And wait, I might already know that one, but why do people have different blood types?
Oh, excellent. Yes, based on observation, that would be an excellent one. Why does a balloon filled with air float over a fan? Oh, I like that. Exactly. Good. And depending on which gas that balloon is filled with, it might sink and hit the ground like a rock too. So that would be another good experiment. Why do some balloons sink? All right, good examples. So we are going to, for this live session, use the question, how does the amount of water affect the growth of plants? Okay, so we could answer that, right? So how would you answer this question? It's a pretty easy question. How could we answer it?
Not enough water would dehydrate the plant, and enough water would be isotonic, right?
Okay, very good. So we could either, oh, I'm sorry, go ahead.
And it would overhydrate and like basically wilt or drown.
Yeah, exactly. So, so too much or too little water could kill the plant. Exactly. So there's kind of a fine line between enough water for the plant to be happy, basically. Good. Thank you for all the participation this evening. This is wonderful. Okay, so next step. So if we're going to use that as our question, before conducting any experiments or dealing with any variables, the answer isn't always as straightforward as the one that we just talked about. So we're going to talk about our next step, which is the hypothesis. So during this step, we're going to try and answer our question by making an educated guess. So if we were to use our example question, what would you hypothesize? Kind of already hit on that. think back to my disclaimer. Some scientists will put background research before the hypothesis state. So their steps might be a little bit different. They might say, ask a question, research, and then hypothesize, instead of hypothesis being the second one. So, because some questions you have to have a little bit of knowledge in order to give an educated guess. So when writing a hypothesis, we are going to make sure that the variables are important and right there in our sites. So we have an independent and a dependent variable. So an independent is going to be that manipulated variable, the variable that I can change for the experiment. So I can, let's go back to the balloon. Why does the balloon float if it's filled with air? Why does it float above a fan? Okay, I could manipulate how much or how little air was put in the balloon. That would be something that I could change for the experiment. I could change the speed of the fan. So the dependent variable is what's going to happen based on what I changed. Okay, this is actually sometimes called the resulting variable, or also known as something that we're watching for change during the experiment. So dependent or resulting. The control variable is something that stays the same throughout the entire experiment. So going back to the balloon example, we could use the same brand and the same color of balloons. Maybe that's going to be my control. We could use the same amount of air and just change the fan speed. Usually when we do this, we are going to write our hypothesis in this form. So we're going to say if I do this, so if my independent variable, then this will happen. So if I change the amount of air, then my balloon may or may not float. Okay, that would be my an example based on that balloon example. So okay, so let's move on to number 3. We are going to gather materials. Okay, and so once our educated guess is made, we are going to have a list of materials. Okay, so for our example, we're going to go back to our original example of how does the amount of water affect the growth of plants? Okay, for that experiment, what materials do you think we need? Okay, I've got some written down. I've got water, I've got plants, measuring cups, soil and light, and a pot or a cup to plant a plant. Sometimes that's a little bit more obvious, but it's still something that we have to gather and get in one place in order to conduct an experiment. So you kind of have to brainstorm and think of absolutely everything you need in order to conduct the experiment. You don't want to have to keep running to the store when you're trying to get everything set up. Okay, so now we have the experimental procedure. This is where we're actually going to test our educated guess, our hypothesis. Here is where we create a step-by-step detail on how we're going to explain or experiment. Remember dialing the phone. I have to make sure that all those numbers are in a certain order to reach my grandma. Okay, if one number is out of place, unfortunately, I'm going to get somebody else. Also, a procedure serves as a recipe in the sense of you should be able to give your recipe to someone else, and they should be able to complete your experiment just as you intended. Okay, so it's kind of a recipe for your experiment. Okay, so during the procedure, it is important to make sure to only change one variable at a time. Why would that be important?
So that you don't get a complex answer or something different than your original changes.
What do you mean a complex answer? Can you explain
Like
that a little bit?
if you were, how do we explain this? If you were trying to get the color green and you mixed blue and yellow, if you ended up adding purple as well to blue, you wouldn't probably get the same color.
Okay, good. Excellent. Okay, why else?
Um,
What other ideas do we have? So you understand what causes the change. Excellent. Thank you, Ben. So what you once you understand the change, that's where the importance comes from. You can't. So if we're doing the water and plants, we can't. Sorry, we can't. Get the right data. So if we're going back to our experiment, how much water affects, how does the amount of water affect the plant's growth? Let's say I'm gonna change, obviously, the amount of water, and I'm gonna change the amount of sun that each plant is going to receive. Well, I'm not going to know which variable is affecting the growth. Is it the water or is it the sun? I mean, obviously, we know both of them are going to affect the growth, but right now we're focusing on the water. So we need to make that a priority for sure. Okay, so why would certain scientists recommend that the procedure be carried out multiple times? Why can't we just do one experiment and publish our research and say, here we go?
because you might not get the same result.
Okay. Why wouldn't I get the same result if it's the same experiment?
It depends on how much each plant will get. Like even the slightest of difference, it might make a different change, maybe.
Okay, good. And we want to make sure that
It's like solid.
I'm sorry.
You need to make sure that it's a solid answer.
Yes, or that we've received the same results over and over and over again. Exactly. Maybe again, Ben, thank you. Maybe the plant is sick or deformed, or let's say partially dead when you planted it. We want to make sure that the results are the same again and again. Thank you, Stephen. Awesome, guys. Good. We can't just, there could be a fluke in, let's say, the water, maybe. I could have high contents of sulfur in my water one day, then no low contents another day, and then that could throw maybe my experiment off. So I need to do them multiple times in order to get the same results. Excellent. Thank you, guys. All right. So here I have the 3 plants. They all have soil, they all have pots, they all have sunshine. Would this be an okay experiment for what we're trying to investigate?
No.
Why not?
Because there are different types. I'm sorry.
Yes, they are. They are different types of plants, exactly. So we could have 3 different types of plants that require different amounts of water. So in this particular example, we would be changing more than only one variable, and that would give us different results for sure. The pots are different sizes. Excellent observation, Stephen. Exactly. Very good. Oh, and Ben, you guys are picking up things that I didn't even notice. Yes, Ben, it looks like plant C is getting a lot less sunlight. Excellent. Thank you. This is why it's always good to have a scientific partner too, because everybody sees things a little bit differently. So if we are going to conduct this experiment, it's going to look something like this, okay? All the same size pots, all the same plants, all the same amounts of soil, all the same amounts of sun. This would be an example of where the only thing that's going to change is the water itself. Okay. Any questions so far? I feel like based on the participation, we're following pretty good. Any questions at all? Okay, we'll keep going. All right, so sorry about my graph being within my words, but I think we can still figure this out. Okay, so collecting data. When we collect data, we collect both qualitative and quantitative observations. What's the difference between qualitative and quantitative? Any ideas?
Maybe, hold on.
So qualitative, if we look at the first portion of the word, it looks almost like quality. Quality is going to be where we involve the words. So we can write a sentence based on the observations. Where quantitative is going to be where we are going to collect quantities or numbers. Okay, so we can have sentences describing what we see, and then we can have quantitative observations such as the chart based in numbers. Okay, so we're going to collect usually in charts or graphs. This is definitely an example of a data chart. So I'm going to ask you this. We have time versus what is this supposed to be? I apologize that it's not. Okay, speed. Sorry about that. There. That should help us understand this a little bit better. I apologize. Okay, so we have time versus speed. Which of those two variables would be considered the independent variable?
What?
I'm sorry?
What was the question?
Which speed or time is the independent variable?
Would it be speed?
Why?
Because speed can function alone, I think.
I can do what?
Speed can function, or no. The goal.
So think back. Our independent variable is what?
The variable that can function alone. That's what I remember.
Okay, it can stand alone. So which of these is going to be able to stand alone on an experiment? Speed or time?
I mean, yeah.
Okay, I'm going to say that speed is going to be my independent variable. Why? Because I can change that. Okay, I can slow down, I can speed up, I can stop. Okay, I have the control over the speed. So that makes time my dependent variable because it's not going to always be the same, I guess, but time is always going to pass. I, unfortunately, have no control over time. I sure wish I did, but I don't. So even if I sit here for hours and hours and hours and do nothing, um, time is still going to pass. However, my speed will probably remain 0. Okay, so like Ben said, independent is controlled by the person, dependent is not controlled by the person. So very good. Thank you. So the dependent is going to be which one is dependent on the variable that I changed, if that makes sense. Okay, so if we look at our data table for our experiment, the amount of water versus growth, the dependent is going to be growth. Why?
Because growth needs water and sunlight. Sorry.
It's okay.
It needs water and sunlight to grow.
Exactly. And there's going to be a certain amount of growth regardless. Okay. So the independent is the amount of water that I have chosen to regulate. Okay. Again, yes, Stephen, thank you. I cannot control growth. I can control it to a point, but still I can't stop it. So my independent variable is going to be my amount of water, which I'm going to change and manipulate. Okay. All right. So this number 6 is step 6 is my conclusion. And again, this is a simple scientific method only using 6 steps, but remember that it could be expanded to 11 or 12 steps. So in a simple scientific method, this is the step that ties all of my work together. Okay. Oh, sorry. Don't be shy yet. What am I doing? Okay. So in a detailed writing, you can answer the following questions. So does your data support your hypothesis? If not, why? What happened? So if my hypothesis said the more water I give the plant, the more it's going to grow. Okay, if my data doesn't support that, then here is where I'm going to explain why. Okay, what was my procedure? What was my recipe for my experiment? And maybe there's something that I would do differently next time. Maybe instead of watering the plants 3 times a day, maybe I would only water them once a day. Okay, or maybe I would look at the different plants. I could maybe look at the very first example of experiment and look at 3 different types of plants, keeping everything else the same. And then finally, talk about what the relationship between the independent and dependent variables were throughout my experiment. In the scientific community, your conclusion is where you explain what you went through. Okay, if you're gonna pass your experiment on to somebody, they're gonna want to know they want to know all the information as if they were there with you, is what I'm trying to get out. Okay, now, please don't be shy. Are there any questions?
I don't have questions on this, but I do have questions on my physics work that we're doing in my other school.
Oh, okay. Okay. There's an assignment that I want to go over. Can you hold on to your physics questions and then we can talk about it after?
Mm-hmm.
Okay, don't go anywhere. I want to talk physics. Are there any questions about the scientific method?
Go to sleep. Go to sleep.
Okay. All right, so let's go ahead and go over the lesson 2.4.1, kind of reflecting on the lesson that we just talked about. This is an activity. So in the following lab problem, what is the manipulative variable? How does light affect plant growth? Am I going to manipulate water, plant growth, or light?
By manipulate, I think it's water and light, right? Or manipulate, yeah.
What am I going to control?
The water.
Well, okay, so we wanted to control the water in our example for the lesson.
So is it the light?
It is the light, yes, because my question is, how does light affect plant growth? So again, I'm going to have everything the same except my light. Okay, good. All right, second question. The controlled variable is an investigation that is what is measured, is not needed, stays the same to provide a comparison, or can be changed. Which of those four would best describe the controlled variable?
Is it the stays the same to provide a comparison? Or...
Yes. Why would it be that? Because you almost asked that as a question and not a statement.
It would be that because stays the same to provide comparison. So that you have a baseline that you're measuring your hypothesis off of, so you can try other variables, I believe.
Excellent. Very good. I like that. Using it as a baseline for sure. Using it again to compare. So I don't have too many different variables doing too many different things. So I always have something to compare to. Awesome. Okay, so the manipulated variable is what you are measuring in an investigation. True or false?
Is it false?
Why would it be false?
Because I think the manipulated variable is the one that you're... Wait. Wouldn't it be true?
It would be true.
Sorry, it's almost 1 a.m.
Oh my goodness. Oh goodness. Okay. No, it's definitely true. But the great thing about that was I could hear you thinking through the questions. So that was excellent. So thank you. And I apologize for being so late or early in your case.
Oh, no, it's okay.
The responding variable is what you are blank based on the changes of your manipulative variable. Is it predicting, measuring, proving, or comparing? The responding variable, or sometimes the dependent variable.
Based on the what?
Changes of the manipulative variable.
Is it proving or predicting?
Okay, well, it would either be one of them, only one of them. It's only going to be one choice.
Predicting?
So let's go back and find where we talked about our different variables. It was a while ago. Let's see where it was. Okay, so we have our dependent variable, or resulting, is what happens because of what was changed. It's what we are also watching during the experiment. So our independent is what's changed. Our dependent is what we are watching. So if we go back to that slide and look at our choices, the responding variable is what we are blank based on the changes of the manipulated variable. Predicting, measuring, proving, or comparing?
Proving.
Proving. I would think that it would be more of measuring. Okay, because if I have the manipulated variable, then I am going to see, no, I am wrong. I am going to say comparing because, sorry about that, because I'm looking and seeing what my independent variable is doing with my dependent variable. Okay, so what I'm manipulating versus what is staying the same. I'm sorry. So it would be comparing. Oh, it's almost 6 o'clock here. It's almost dinner time. Can I blame it on my empty belly? Sorry about that. Okay, so number 5, we are going to, well, here are my answers. So I am going to, number 1 is going to be where I'm going to state the problems, and actually, let's see if nope, my answers are still there. Okay, so if I look down to number 4, this is going to be my very first step. So state the problems or ask the question. That's going to be where I start my scientific method. Then I'm going to make a hypothesis, educated guess. Then I will sit down and gather all the materials all at once, thinking all of the obvious as well as the not so obvious materials. Number 4 is going to be where I'm going to actually carry out the procedure, where I'm going to experiment in a certain way, certain method. I'm going to collect the data, whether it's qualitative or quantitative, as my next step. And then finally, my conclusion is where I'm going to write all the information down. The conclusion is where you want it as detailed as possible. So again, somebody that just walked in the door can figure out exactly what you saw in your experiment. That's the cool thing about the conclusion. Okay, so now do I have any questions about that activity?
No.
No? Okay. Awesome. Okay, so let's go on and quickly talk about time management. Okay, time management is always something that we need to focus on, whether it's as a student, whether it's as a resident of your own home. There's certain things that you always have to worry about time management for. So I like to stay organized. I like to have a certain place where I do my work, where I have all of my materials, like in our experiment, all in one place. Okay, so I feel like as a student, I would not be able to do my homework if I wasn't organized and I didn't have my textbook with me. The final bell rang at the end of the day. I grabbed my book bag, forgot my algebra book. That's going to be hard to get my homework done. Okay, so making sure that you have a spot where all of your things are, making sure that you have a list of things that you need will definitely help you focus on the task at hand rather than, oh man, I don't even have a sharpened pencil, now I've got to find a sharpener, things like that. Okay, so a calendar. I love calendars because I like to check things off. If I have a super busy week, I like to create a weekly list of things that need to be done. Whether it's, okay, my 5-year-old has soccer practice, I've got to grade papers, my husband has to work, things like that. Then once they're done, I can cross out. And that's that's very gratifying for me because I've accomplished something, and it's visual to me. I can see on paper, I did this, right? This was successful. Scheduling. Make sure to schedule me time. And it's very important because sometimes we get stressed out, we get tired. Oh, I've got to study for this physics exam. I've got to study. Well, you can't hardly take care of yourself when all you're doing is studying. So maybe a 5-minute walk, or just a snack or something. It helps greatly just to kind of refresh your mind. Prioritize and schedule what you need to do. Be realistic. If you work 8 hours a day, you're probably not going to be able to set aside 8 hours for classwork. It's not realistic to be that functional. Unfortunately, I wish it was. But again, making sure that you have specific study time. Like, I'm going to study every day for an hour and a half, or I'm going to get an assignment done every night and stay on schedule. So it just kind of depends on your life to see what's going to be realistic for you. Reward yourself when things are done. When you can check those things off the list, reward yourself. My reward is a piece of chocolates. Sometimes the whole chocolate bar, but and that would be my reward. Or playing a game with my kids, something to kind of get my mind away from my task, what I need to do, okay? Make sure you take those times to relish in what you have done, because you are definitely amazing, and you're definitely doing great work. So those are just some tips to staying up on your time management. I know things work differently for different people. Have you guys found something that works a little bit better for yourself? Maybe that I didn't mention?
For studying, Quizlets are better, and taking a lot of notes.
Okay.
You don't need them.
Yes, very good. I like to write things down because it helps me remember. You know, the motion of writing it down is helps it stick in my brain a lot better. If I do like notes, and I've learned my husband works better if he sees a note as well. Anything else that you would care to share?
Also, if you give yourself an hour break after school and then go to study, it'll be easier.
Yes, very good. Yes. Let's see. All right. Brain breaks. Yes, very good. I like that, Stephen. It's sometimes just to step back for a bit. Exactly. I used to work for a principal. He called those 5-minute vacations, where he would just take a brain break. Exactly. Just a 5-minute vacation. I like that. Yes, very good. I play solitaire. Nice. That's awesome. All right. Well, are there any other questions about this session? I know, Nora, you have some physics questions, but anything else that I can help you guys with?
No.
Thank you. Thank you for joining. And feel free to always email me if you have any other questions that you would like extra help on. That would be great. That's what I'm here for. So, all right.